Okay, guys. So I sent you the software called as the Design Spark. That is a PCB designing software. So as we already completed one experiment yesterday, so just wanted to show you how you can convert that experiment into a motherboard. How to design the motherboard of that particular experiment. So this is the experiment that we completed yesterday, right? So smart street light, like without any kind of embed system or any kind of coding, it's a straight away concept. That is, you are taking the intensity of light and you are doing the task of controlling the transistor. Through the transistor it is controlling the relay, and through the relay you are controlling the high power supply. So this is what the concept. Clear? So now we have to see how we can convert this into motherboard. And see, guys, like now we are entering into the new technology, like a new technology for you people, that is a design, like a PCB design. Okay. uh, yeah, this is yesterday link. See, this software no preview is available, it's showing right here. You can see three dots. Not here, it is from my account only, right? That's the reason.
Sir, I'm facing the same issue, sir.
Okay. Yeah, now you will check it. The same link, actually. Yeah, I sent the new link in the WhatsApp group. You check it whether you're able to get this. Yeah, whether you're able to get this one or not. Check it. This window you can see, right? This window you're supposed to get. Confirm once you got it.
Yes, sir, we are getting.
Okay. You can see here there are three dots. Just click on download. Yeah, once you completed the download, just cut it and paste it in any one of the proper folder. And just expand it, extract, extract all. Okay. So once you extract it, you can see there is a folder called the Design Spark. Yes. Are you able to hear me?
Yes, sir.
Okay. So you have to just double click on this .exe file and click on yes. And please follow the steps properly because we have to enable a certain things from the backend. That's the reason. Don't go to the next level without my instruction. Click on next. Here you can see there is a concept called as the unpack files. Second option. Unpack file. Second option you can see here. So go to second option. Click on change. Go to your folder where you saved this particular PCB software. Yeah, see here inside this there is a folder called as the Design Spark PCB. Reach this level first. While installing the software, I want you to be carefully observe the screen and do it. Okay, click OK. Next. Okay, after selecting the folder where it has to extract the file, you have to click next. See guys,
Sir,
what
your
is that?
screen was like
Yeah,
your screen was like 10 seconds was muted. Like it didn't show.
muted. No, you copied that file, right? After copying the file, you extracted the file, right? It was a
Yes,
compressed
sir.
folder. It was a compressed file like this. After compressed zip folder, you have to extract it.
Yes, sir.
After
Yes, sir. I done, sir.
after that, you go to the Design Spark version 8 educational.exe. Okay. So double click on that. You will get a further screen. Click next and select a second option, unpack.
Yes, sir.
Then click on browse and go to the location where you saved this particular extracted file and select that location. After that, you just Design Spark question 8. After that, you have to just click next. You have to wait for the screen to complete and you will reach the stage. At the moment you reach the stage, you can see the file is extracted and you got extra like these files. Okay, in this you select a key lock. In this you select a key lock. Okay, go to program files. Where you will be having this file is very simple. The where you extracted, right? Inside the extracted, you selected already that extracted folder location. In that location, you will have a key lock. In the same location, you will have program files. Select program files, double click, Design Spark 8. Okay, see, again I'll show you. So this is the folder where I extracted. So in this folder, I have a Design Spark Educational 8 as well as Design Spark, Key Lock. Key Lock is also there. Design Spark version 8 is also there. Key Lock. Then go to program files, Design Spark 8.0 and paste here. It will ask for a replacement. Click on replace file destination. Everyone completed replacing the key lock file. No hesitation, guys. Please let me know anybody is facing issue. Yes, all of you are at this stage now.
Yes,
Shall I
sir.
wait? Purvika, how about you, ma?
Yes, sir.
Yeah, you reached this stage. It's whatever screen I'm showing now.
Yeah, sir, but some network issue.
No, you downloaded a file, right, from the drive.
Yeah, sir.
Then you followed the steps and reached this stage, right?
Yes, sir.
Yeah, Sheetal, Shruti.
Yes, sir. I downloaded it,
Hmm.
and the screen is showing license agreement after the. I click the next option in that one. Yeah.
This one, huh? Okay. Huh.
Yeah, that one. That one.
How about Hemant, Shruti?
Yes, sir.
Okay. So you have to click next. So it will show license agreement. Just click on accept terms and license agreement. Click next. So company name, you can give your name. Company name, Indian Techies. Next, next, next. Finish. So now it is installing the PCB design software in your laptop. Yes, once this is done, click on launch application now. It will launch the application. Click no. Now Design Spark 12 is there, but we can go with the 8 only, the basic version. Click no. So now you can see this particular window is opened. Okay. So I'll just give another 5 minutes. So people who are lagging, please reach this stage quickly. This is one software that we're using for sake of motherboard design. Okay. And in this software, as you can see here, we have a very good options. Up to 14 layers we can design by using this software. Okay. So first thing is library. We have to start with the library importing. Click on library. Okay. This is just like a by default we'll have a less number of libraries enabled, so we want to go with the more number of libraries enabled. That's the reason you have to click on library, click on OK. You can observe there are multiple tabs are available here. Okay, go to folders tab. Okay, if you go to folders tab, you can observe only 16 files found here, only 16 files found here. So we have to go for enabling the library folders, and here you can see folder found now is 203. Folders found is 203. Okay, then again click on add. So whatever folder I asked you to download from the internet from our drive, right? So in that folder we have additional library files, so that library files also we have to include. So in order to include those library files, first everyone reach this stage, because during the software installation if you miss any stage or if you're lagging, please let me know. Once I start with the design, you should not be lagging or become stuck somewhere in the middle. Okay, and here you can see if I click on add, browse, I have to go to the folder where that particular files are there. See here you can observe there is a file called as libraries. There is a file called as libraries. In this library file, downloaded libraries, and you can observe there is a bridge rectifier.cml. Just double click on this, press OK. So we have a 228 files found now. Again, add, browse, just click one level, add, browse, click up one level, and you can observe here user.ca. So 232 files found now. Okay, these many number of files we need at least minimum. It is not something like we are using more number of libraries, just the minimum number of libraries that we need. Okay, and by using this particular project, you can develop a motherboard like this. Just showing you. Reduce the magnifier. Here, like this motherboard can be developed, and you can see the 3D view of that motherboard. See, like these things you can do. The backside tracks, front track, all these things you can do. Okay, so this is the software that we're using for designing the motherboard. So as you already know, we have like one project that is like already simulated in the Tinkercad. Yeah, so this is the project. So if you observe in this project, we have few discrete components and few power supply related component, and directly we're using the 230 volts power supply. Okay, and we are using the like a DC source, but generally we will not have a DC source directly from the 230 supply. We are supposed to create our own DC source. That means we have to get a DC from the AC. And see, in this entire diagram, if you observe here, so in these 2 points we have to use a screw connector to put actually the bulb will have a wires, right? So that bulb wire I have to plug like I have to connect in these 2 points. So you have to use a concept called as a screw connector. I'll show you. We have different types of connectors. So generally for bulb purpose we are going to use a screw connector. Yeah, you can observe like this screw connector. 2 pin, 4 pin, like this diagonal screw connector. Okay, this is the PCB mountable. Okay, in your college labs, in the college lab like circuits, you might be seeing like this screw connectors. Yeah, but you can't directly search like a screw connector in the library. There will be a separate part number for that. Okay, that is the one thing. And here also for this one, whenever there is a high power signal, we're going to use a screw connector like this. Whenever there is a low power signal, as you already saw in the 3D view of this particular board, you can observe here, they are using the small pins, right? These type of pins we are going to use for low power. Clear? These kind of pins we are going to use for low power. So that is nothing but that is called as a buck sticks. Bur See, PCB, what happens, guys, if you want to become a masters in the PCB, so you should also have a knowledge of the, like if you are assembling the PCB board, you should also have a knowledge of the components. So this is called as a bug sticks, bug sticks. Understood? So these type of connectors we're going to use. So before that, all these things, first we have to create a project. So in order to create a project, first we have to file, new, So you can observe here we're getting the different options, right? Click on project, press OK, software. So you just select the folder where you would like to save it. Yeah, I'm just using it as a smart light. Okay, I just created a project called as smart light. You can observe there is a project called as smartlight.prj. Hope everybody is able to create up to this level.
Yes, sir.
Okay. Remaining, if you are lagging, please inform. Don't hesitate. Then again go to file, new, schematic design, press OK. And in this schematic design, you select again same folder, and give a same name. And see, when you type a beginning letters only, it will tell you the complete name. It will show it, but you should not select directly. You have to remove the .prj. Project comes with the extension called as the .prj, whereas schematic comes with the extension called as the .sch. Okay, press save. Okay, so now we have a schematic. Schematic is nothing but a virtual circuit, guys. So same like how we did in a Tinkercad, in the schematic we do with the real components, connections. Okay, and see here, as you can see here, you have to click on add component. So as soon you click on the add component, you are going to get a window like this. And here there are two slots are there. One is a library selection window, one more is a component selection window. So in the library selection window, select all users, sorry, all libraries. So it should be always all libraries. It will scan everything and keep it ready for further work. Just wait for some time. So it will give option to enter the component name. Yes. Now you can observe we got components, and see guys, there is a one option called as a preview option. Click on this preview. When you click on preview, you can observe two more small windows opened, right? When you click on the preview, you can observe two more small windows opened. So these two are nothing but the one of white color is a schematic uh, symbol, black color is a footprint symbol. It's supposed to have a footprints. So if you are having the only box like this, so this is nothing but a not a real component, it is a virtual component. It is also called as a schema component. We are not supposed to use such components because footprint is the area where you're going to solder the component. Footprint is the area where you're going to solder the component. If you are not having the proper footprint, you can't solder that component on the screen, that means on the board. So that's the reason you are not supposed to use any component which has only schematic symbol, not footprint. Rule number 1. Rule number 2 is select the appropriate package. Why I am telling this one is, see guys, in the PCB there are multiple packages are there. PTH is there. Again in the PTH we have a dual inline package, single inline package, quadrature inline package. Clear? Single inline package means only one side you will have a component. Okay, only one side you will have a pins. Dual inline package means multiple side you will have pins. See, if you type a PCB package type, you can see different types of. Okay, this is a PCB. Yeah, here you can see like a. Yeah, you can observe your different types of packages. So BGA, EBGA, CLCC, CNR, CPGA, FDIP, dual inline package, right? So like this, you have a different packages in the PCB. So you should have a clear idea of which type of component you are looking. So the general package that we suggest, like we, this one, like we generally prefer is a single inline package, where in a single line you are going to get component pins. Dual inline package is also there. Like a dual inline package means both the side will have a pins. Okay, so you can take some time and go through the different types of packages, and that this background study you have to do by yourself. That is the assignment of the day. Okay, so you have to figure out different packages required and when we have to use which packages. That study you have to do background theoretical study. Clear? Yeah, as of now, if you can see the requirement, this picture. So in this picture, as you can see, everything we are having like either dual inline package or single inline package. We don't have a quadrature inline package here. Okay, that is the one thing. So now, so first thing, what I want is screw connector. So I'll start from one end. So I need a 2-pin screw connector for this, and for this. Okay, and let me not use a battery, guys. Instead of using the battery, I'll use a converter from 230 supply to low power. So first I will use a screw connector. To get a screw connector here, 2-pin screw connector, 282836, 282836 -2. This is a screw connector. Of course, you may get a one doubt, sir, how to remember these things. See, this all comes by experience. We don't have any option because we have vast number of pins. So, like, you may not be able to remember everything, but it's all about practice. So, screw connector 2828 36. Okay. After screw connector, one is input screw connector. So one more is another screw connector. So in between these two, we are going to use a transformer because here I am getting 230 supply directly. Okay, and I want a low power for my complete circuit, right? I can't directly go with the high power. See, either you can use a normal step down transformer. See, like this, you are going to get a step down transformers in the shops, which has a center tap step. Again, in the transformer, we have a different types: center tap, one-to-one transformer, that you might be knowing. Okay, so this is a step down transformer. We are stepping down from high power to low power. Like this, you will have a high signal, sorry, a high power supply followed by low power. It is going to give the low power. If you are using the center trap transformer, you have to use a 3-pin connector. One end 2-pin, another end 3-pin. Okay, if you're like otherwise, see here what happens after taking this transformer. Again, we have to take a bridge rectifier like this. See, like this bridge rectifier component we have to use. Yeah, like this component, bridge rectifier component we have to use. We have to convert from AC to DC. That is one option. Otherwise, there is a one more component called as a H-link. This is a industry component. This type of component, H-link. So what H-link will do, it will directly take a AC and it will give the required DC. See, this is a 9 volts, 1.1 ampere H-link. It does not require any kind of transformer usage. We don't need to use any transformer for this. Understood? Directly we can use. We don't need to use any transformer for this. That is what the benefit of H-link. If you observe here in this demo circuit, whatever they already did, so directly they gave a 230 supply and they are using a one fuse for safety purpose. Then directly they are using the H-link. It is taking the AC and giving the required DC. See this H-link, whatever you are able to observe here, it is a 3.3 volts DC and 0.9 amps H-link. Like this, you are going to get a different H-link. According to your requirement, you can purchase and you can use it directly. So no need to go for a like a big transformer followed by circuit, many more components. You can, instead of that one, you can go with like this small H-link, small tiny package, which is just a 4-pin device. Okay. Now you get a one doubt, sir. Where is a H-link in our component? How to identify H-link here? First thing is, you have to search in your library whether the H-link is present or not. Let's check it. If not, we have to download externally from Design Spark website. Any doubts till this point? Okay, so if you type H link here, see you're not getting. If you type a H link, you're not getting anything here. Okay. So here now H link I may not be able to directly get it here. So where to get it is very simple. You have to go to a website called as a component search engine. Components search engine. Component search engine. So you can observe there is a website called as component search engine. You click on this, and this website requires you to log in. If you are a new person, please register. Since already Indian Techies account is there, I am logging in. So I will give 5 to 10 minutes. Please register and let me know once you complete with the registration. It's a free source, no need to pay anything for that. Just register and let me know.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, here you type H-link 5 volts because you need a 5 volts H-link now. Just type a H-link 5 volts. You are going to get many some other parts also will be here. It is not something like exactly what you expected, so we have to properly search it. If you are not able to get it here, then you have to create by yourself that particular just a minute, it is XLK4 that is 24 volts. Mm, yeah, we have H-link. So here you can observe there is a single inline package H-link. So in the same line we have H-link. So in market actually we get a quadrature inline package, sorry, dual inline package. So let's check this one. 24 volts to 5 volts it is. That's what data analysis is also one of the required stuff for the, yeah, here we have a 12 volts 3.3 amps. This H-link we can use, and we have to purchase same thing from the market. It's very simple. So 12 volts 3.3 amps we are getting. Same way I'll just copy this number and I'll mention, instead of 12 let me mention 5 there. If it is there we'll get it directly. Okay, it is not available. 05. Yeah, actually it is not available. It's not that. HLK. Well, yeah, let's use a 12 volts only. We have to just use a 12 volts relay for that. That's it. Yeah, I'll take this. You can search by this particular number, HLK40M12. HLK40M12. Okay. So you can observe here it is showing all the three things, symbol, footprint as well as 3D model. Just click on this particular model by clicking this. Once you click on this, you can observe something is downloaded here, lib HLKM12. Okay, so you have to go to downloads and you can cut it from here, Control X, go to your software. So in the software, anywhere you can just paste it. Better I will paste it in the library folder only. Anywhere you can paste it, but I will paste it exactly in the library folder. Then I click on extract all. It will be extracting with the same folder name. Okay, so once it is extracted, see this is the number HLK40M12. We have to go to Design Spark. In the Design Spark, go to again library. Go to schematic first, schematic symbol. Click on add file. And here you can observe, you have to go to the folder where you saved it. Libraries and HLKM12. HLKM12 in this Design Spark m12.dsl and click on OK. Now go to PCB symbol, add file, HLKM12. Again click on component, add file, sorry, by mistake I selected the user CML. Mm, yes. Now you can observe HLK 40 M12. I got one component, right? Yeah, 3D view we are not able to add. That is the compatibility is not there. Many times we also tried it. It's not compatible. Okay, it's coming. Let's see. No, it's not coming. It's again same thing. This one only is showing. Yeah, 3D we may not be able to get it. It will come like a box. Let me check it once again. Saving option. Okay, now I would like to add that particular HLK component to my schematic. I click on add component. Yes, make it all like this only. Here you type HLK. Yeah, you can observe. We got a component. Click on add. Yes. So here, if you would like to rotate the component, you just click R for rotation, or you can click F for flip. Either you can click F or you can click R and finally rotate it. Okay. Now, finally, what's happening here? I got a AC to DC, and I am going to use this two connector for bulb purpose. I'll use this two connector for bulb purpose. If you click on this, it will automatically increase the zooming. fit to the screen. Okay, don't connect now, just wait for some time because we have to figure out few other components also. And see here, here I'm giving the AC and here I'm getting DC because of a H link. Then click on add component. And here I'm going to use a small LED for indication purpose. LED. These are all the additional things I am trying to do. So just to give the indication regarding the component. Yeah, here for LED resistor is required. Okay. And I need a this is just an indication whether it got powered up or not. So next concept I need is the relay, sorry, LDR. Yeah, this is the LDR model. Okay. Along with the LDR model, anyhow, as you know, we are using one resistor for transistor. So now I need a NPN transistor. You can type BC547. That is a NPN transistor. Okay, BC547. This is a transistor, and as you can see, emitter base collector they give clearly, so you have to connect accordingly. Okay, and output of this transistor I'm going to connect to the relay. Here you'll get all the different types of relays, guys. DPDT, DPST, SPST, SPDT. See guys, whether it is an embedded system or PCB or any technology IoT, you should have a very good grip about the core electronic components first, discrete components. How and which type of components are there. See, this is what we need, 5-terminal relay component. Right? Take a relay underscore new user, and this is the component that we need. X. So this is what our requirement. So all of you reach this stage and let me know. Yes, are you at this stage now? All the components you collected? Yes, anybody is lagging? Okay, so now you have to select all. Okay, you have to select all, then right click and properties, because extra information is there now. All those extra information has to be cleared. So uncheck component, uncheck package, uncheck pin numbers or pin names. Let it be pin numbers. I will uncheck. If I click on apply and click on this view all, you can observe now the entire screen is refreshed. Now I don't want it to be referred as a J2. I'll rename that particular component. Okay, now to rename that, double click on the component. Instead of J2, mention it as power supply. Same way, instead of J1, mention it as load. Okay, and this is as it is PS1. No need to rename nothing. Remaining things we no need to rename. Okay, then I don't want this text to be displayed, so to change the text, okay, you have to go to settings. You can observe this symbol. Either you can go to settings and technology, or press shift plus T, or go for click on this symbol, anyone. Either settings and technology, or shift plus T, or select this symbol directly. You will get like this one particular sub window. Click on textiles, and here let me select a Times New Roman, because that is enough for the all the type of text. Okay, right click, apply column, and 100 width. Right click, apply column, apply, and OK. Now you can observe, so we have a like good this one fonts, and this is additional one. You just select and delete. Press select a delete option. Select and delete. Okay, now we have to do the connection. Of course, AC connection is as it is, and to start the connection, guys, we can observe there is a cross mark is there. Now double click on the cross mark So as soon you start connection, it will start like connecting from one end to another end. You can observe the wire is establishing. By mistake, if you left any connection in the middle, you will get like this pink color, which indicates incomplete connection. So make sure that you should not have any such kind of pink color connections. So continue the connection. So now see, you can observe now it's complete. Same way, output. So output you can use as per your requirement. So this is a ground connection. I'm going to connect the ground to the cathode, and I'm going to use an anode through resistor to avoid the damage to the LED. Okay, then LDR. See, as per our circuit diagram, you can observe here yesterday circuit diagram. So this is the plus sign minus I'm getting. So plus minus symbol I'm connecting to the emitter of the transistor. Minus symbol is this one. I'm going to connect to the emitter of transistor. You can observe whenever I'm connecting in the middle, I'm getting junction. If I'm connecting from component to component, there is no concept called as a dot. Junction is not created. When we connect it from component to any mid of the any wire, then dot will be coming. That is junction. Okay, component to mid junction. Then resistor like as per the connection diagram, you can observe resistor supposed to be connected to the emitter as well as to the base. Emitter as well as to the base. So I'm going to connect. Instead of keeping this one here, let me rotate and keep it here. Otherwise I can flip this component, so base will come here. Like this I can flip it. F for flip. Okay, so now you observe like we have a LDR as well as we have one fixed resistor. Okay, so LDR, let it be here, and a fixed resistor, one terminal I'm connecting to the base, one more terminal to the emitter. Okay, LDR also same thing, one end to the base, one more end to the plus, positive, and like a collector I have to connect to the coil. So this coil is instead of here I'll connect to the top. Coil is an unpolarized device, guys. You can connect either to the top or bottom, no issues. And one end of the coil is connected to the ground now indirectly. Whenever the electrical supply is connected, base will be triggered, means emitter will be reaching the collector. So indirectly ground will be supplied to the coil. One more end of the coil we are going to connect to the output. Same thing like a previous circuit, this particular connection. Okay, and with respect to the load, as you can observe yesterday, one end we connected to the main supply neutral, phase we are switching through the relay, right? Same way here. Collector, that means common terminal, I am going to connect to the one end, and as you can see here, yesterday we were using the normally close. So normally close I am going to connect to the bulb. And see guys, if the wires are crossing like this, it's not connected. The wires are crossing like this, it's not connected, just a overlap, that's it. Then one more end is connected to the main supply. So indirectly, neutral is directly connected, phase is connected through the wire. Sir, I want to get a different colors of wire so that I can understand clearly. Means select a wire. There is an option called as a change net color. Change net color. By default, it will be this one, black color. You can change it to red color. See, this is now phase. Same thing here also, positive. So change net color, change it to red color. This is a DC positive. Okay. And also you can change the width of net. For AC positive, I'll give it as a 15, so that when it will become very big. You better use power. Automatically it will become power is also not having there. Right. 15. Yeah, I can observe here. So this is the power. Power is becoming 15. So high power, like connection, I'm making it as 15. Low power, it will be as it is. Like this, you can even change the thickness of the virtual connection. It is not actually a track. It is just a connection thickness. Understood? Just to indicate that one, those are all high power. Otherwise, sir, I don't want like this individual thickness to be maintained. I want it to be automatically planned. So what you can do, guys, if you want automatically the thickness to be like a, the power lens has to look like a high thick, and the remaining lens has to look like a normal thickness. See here, you have to go to settings. In the settings, there is an option called as a net classes. Net classes. Okay, in the net classes, power, check for is there any edit option. Yes, there is an edit option. Type power, but thickness wise it is not there. Let here also add AC power. No, that line. Okay, line styles. Yeah, here it is. Line styles for power. Where is the power here? Add a style. AC phase. AC phase, and we can even use a different this one also, dotted, dash, dotted, all these things. Solid. Let me use a dotted for AC, and I want to pick like a value to be 50, 35. Apply. Now let me see here. See here. Now I'd like to make this as the AC properties, and here it is asking for style. Okay, let it be. Do it individual thickness maintenance only if you need it. It's not coming for everything at a time. And the style it is not there. Okay, like this you have to complete the circuit. So load and power, all these things. And since we don't have any kind of DC supply, we don't take the polarity. We can directly use it without using the polarity. Okay. Okay. Up to this stage, everyone finish and let me know. Yeah, one more changes we supposed to do, that is we should not use a 1K, as we know yesterday we use 100 ohm. So to change the value of any component, if you want to change the value of any component, you have to just double click on the component, go to values, instead of 1K, edit and make it like a whatever value you need, 100 ohm. Apply. Okay. Now you can observe it is mentioning as a 100 ohm. So you can display that as per your requirement. Just a minute, let me check whether yeah it is having both symbol. Yes, in WhatsApp group I sent the diagram. So refer it and complete the circuit. Hope you know how to do it. Red color, black color, thick one. Okay, that you can check from your end. Please let me know if anybody is having doubts so that when I can repeat the steps.
Sir, after the session, can you send the recorded just for the reference purpose, sir?
Yeah, I'll send it. In YouTube, you can check Indian Tech is. Our company channel is there. So in that channel, we'll be uploading the video.
Thank you, sir.
Yeah. So whatever we did till now is just a schematic design. It is not at PCB design. Okay, and in this particular software, we don't have a simulation. Virtual output we can't get. It is just a schematic design. And to know whether this is confirmed properly designed or not, you can go to tools. There is an option called as a output. There is an option called as a reports. In the reports, click on unconnected pins report. Click run. So this is going to show you how many pins are unconnected. So as of now, unconnected pins report is 1. So here if you observe, we have a known unconnected pin. The pin which is it is showing number, whatever it is showing, it should be known to you. Yes, it is unconnected because it is not required for any kind of work. It is a normally open pin. Okay, like this you should have a confirmed unconnected pins report. Confirmed unconnected pins number. Any doubts? Any other people? Are you feeling complex? The concepts? So once this is done, guys, we have to go for a layout design. Whatever we did is only a schematic design. The next one is layout design. So to convert from here to layout, you have to use the tools, translate to PCB. Tools, translate to PCB. And first time it is going to ask you this particular question. Like this particular checkbox. Click check. Next. And see here there is an option called use default technology, choose technology file. So select choose technology file, let it be default only. And unit, guys, generally what happens in the PCB, we use a unit called as a thou as well as the mil. Thou as well as the mil. Yeah, you have to use, you can use anyone as per your convenience. Since you are a beginners, you can use centimeter. Later while exporting, we can make it as a thou or mil, no problem. Click next. Select, like what was the previous step is very simple. Choose technology file, default centimeter. Next, define layers. So single sided board, because you should be very careful with respect to the layer selection, guys. Whenever the number of layers are increasing, automatically the cost of manufacture will increase. Single layer means you are going to get give a price of 0.6 or 0.85 say 80 paise or 60 paise per square centimeter. It is. If it is a dual layer, 2 layer means it will be a 1.5 rupees. If it is a 4 layer means it will be a 20 rupees, 25 rupees like that. So it is going to increase. For a small circuit, you should not simply go for 2 layer. I said now you are into the product development internship. So you should try to manage the cost cutoff from everywhere. With respect to proper embedded system design, with respect to like a proper microcontroller selection, from all the angle you have to reduce the cost. Okay, so define layers, single sided board. Then next, define board size, let it be as it is, later point we can change. Next, arrange outside the board, automatically position inside the board. You can select automatically position inside the board, allow component rotation, but don't allow second one. Allow SMD component to swap. As of now, currently we are not using any kind of SMD components. Okay, no need to worry. Then click next. Keep the name as it is. Finish. Yes. You can observe you got a component like this. The like a one black color window. This is the actual footprint. Actual PCB layout is this one. This was only schematic. But if you make any mistake here while doing the connection, same mistake will carry out even for the PCB layout. Finally, your circuit will not work. Okay, you should be very careful with respect to this. And here we are using the concept of arranging the components. So I'll bring everything inside first. And you can see a 3D and 3D view. In the 3D view, you can see this is how your components are currently placed. And backside, if you observe, nothing is connected. Okay, nothing is connected. There are no tracks. So now what we have to do, first I am going to arrange the components. So you can observe, if you click the component, you can move it easily. So this is the power supply component. So power supply component, I want to be near the, see, if I place it here, it is taking the connection from here. If I place it near to this, it is taking the connection from here. So let's place it near to this. Then take one more connection for output purpose. So what you're supposed to do is you have to place it near to each other so that you should save the space. Most important requirement is saving the space. We should not waste the space. As I said, the price will be per square centimeter. You have to keep it as near as possible. And this strategy comes by the practice, guys. See, I am placing it near to each other because I would like to save the space. If you observe the screen now, slowly I am arranging it. Step by step I am arranging it, right? See? Yes. Now you observe the screen. So now it is looking like this. Here we have a switching circuit. Here we have a power supply connectors. Okay. So once this is done, but still if you see the back side of it, we don't have any tracks. So now what we have to do, we have to reduce the board size. We have to fit it as per the requirement. And here you have to get a exposure for type of the error. See guys, by mistake if you place any component near to the board edge, you are going to get an error called as a P2B error, pad to board error. So you should not get such kind of error. Second thing is, in case if you place any component on top of each other, you are going to get an error called as a CM to CM error. Component to component error. You should not get any such kind of errors. You should place it properly. And also if you observe here, components are moving in a steps. Component is not moving smoothly, right? Either it is moving here or here, it is not moving in between. That is because of the grid setting. You can observe the setting grids, and here it is 0.013, make it like a 0.001. Okay, if you make it 0.001, now you can observe the screen, smoothly we can move. See? Okay. Now you go with the concept of routing. See? Even while routing also there are few rules you have to follow. By mistake, if you routed it like this, you are getting an error called as a T2P error, track to pad error. That means track is passing over the pad, it will become short circuit. You should avoid it. By mistake, if you took a track very near to the board edge, see T to B error, track to board error. That means track is near to the board edge. So you should avoid it. Okay, like this you have to place it carefully. So like this, one by one you can do the routing. Actually, manual routing is the best routing compared to automatic routing. We have an option of automatic routing, but automatic routing may not give you the good result. Sometimes it may give the result which is not 100%. So this is the manual routing. But if you observed here, this size became more, whereas this size is less. But actually in reality both size should be high because both are 230 supply devices. If you want this particular size to be more, right click, change style. There is an option called as change style. So here apply to all segment. Okay, once again I will show you. Right click, change the style. Let me make it like a 20. Apply to all segments. See? Now the track would become 20. If you press yes, you will get that option, change style, or you can right click and you can select. Same way here also. This is a high power. That's the reason I will change the style. Okay. So this is for change style. So like this, one by one, you have to complete the connection. See now, here the size of this one I manually changed. So now the size of this one is 0.04, signal normal. Okay. So instead of manually changing it, if you want automatically set it, you have to go to settings. In the settings, there is a concept called as the track styles. In the track styles, signal normal, you can make it like a 0.06 power. See here, automatically the size is increased. Now wherever you are going to use a track, automatically it is going to manage that. Okay, like this. But as per my experience, guys, I suggest you to avoid these kind of tracking through the pad, because when you drill the hole, there is a chance where the connection may disconnect. So try to have like this alternative connection. Okay, don't track do the routing through the pad. Avoid the routing through the pad. Please try to have like this parallel connection. Even though this hole is completely drilled, still I should have connection between these two tracks. Okay. Yes. Now you see the screen. Connection is perfect. All the connections. So as we got a single pad, right, which is unconnected. You can see single pad which is unconnected. But sir, I don't want this to have a very small pad. This is called as a pad actually. I don't want a very small copper layer around the pad. So in that case, you can change the pad. See, you can make everything square. Compared to circle, square pads are good. sorry, compared to circle, square pads are good. You can select a pad and go to settings, and you can observe there is a pad style. So by default we selected round, you can make it square, and you can change the size. You can observe here become a square. You can like if now which and all belongs to that particular category, everything becomes square. If you want everything to be square, just make everything square. See, wherever X is there, right, which indicates it is used. Okay. See, now if you observe a 3D view, okay, compared to previous, now we have extra space. Sir, I don't want to edit in general. I want to edit separately only that pad I want it to be having, since anyhow we don't have a more amount of this one, right? Like a parallel, we don't have much pads, this one copper here. That's the reason I would like to edit only these two. So what I will do, I hold control, select both, right click, properties, and see here pad style exception. If you mention pad style exception, only those two pads you can increase the width. You can change the style. So you can change the style only for those two pads. It will not disturb similar category pads. Only those two pads will be changed. So let me make it like a 50. So now you observe only those to become wide, and I don't have any issue because anyhow other like there is no nearby track. I can make it as much as possible my requirement. Why I am doing this one, I want it to be soldered strongly to the board, sir, but holes become very small, sir. The like holes of this particular component, like pins are wide, so it won't suit for my requirement. Then what you can do, you can properly check the data sheet of that particular component, and you can change the hole size. That option is also available. See here, hole size 0.12 mm it was given. I'll make it like a 0.2 mm. See, hole also increased. Understood? Like this, you can select the pad whichever away from the circuit, and you want to make it like a select the pads which are good for the increasing the pad style. Okay, you can select all those type of pads, go to properties, pad style exception, give a common width, and style also you can make it like a square commonly. Apply. You can see everything is applied. So I don't want only 20, I have enough space. I'll make it like a 25. Yes, I have some more space. I can make it like a 30. Okay, if you want, you can go with the different space for a different holes. That is also possible, as you know it already. 0.15, 50% hole I will have it. Clear? See, you can observe now. It is having the circuit. But in this one, you get a one more concept called as a copper plating. If you see any PCBs, See here. So you can observe the PCBs, whatever you are seeing here. So here you are getting extra concept, right? This is called the copper plating, copper pour. Okay. If you want such things to happen here, actually for giving the common ground, we do such kind of copper pouring. Okay. First thing what you have to do in this one, which is the ground signal, you have to identify. Out of these two, which is the ground signal, you have to identify. So if you keep a cursor on top of that, it is not showing. You can do one thing. You can go to component pin names. Let me check whether it is showing now. No, it is not showing. Go to schematic. In the schematic, guys, you can observe here PS1. Okay, double click on this. Enable pin numbers. Yeah, 3 is minus ground, 4 is plus. 3 is ground, 4 is plus. Otherwise, what you can do, you can right click on this. There is an option called as a change net. Okay, in the change net, you are not having the concept called as a ground. In the change net option, you are not getting the concept, like there is no option called as a ground. So what you can do, you can go to settings. You can create your own net. Net, add DC ground. Net class is, it is a power. It's a ground. Own color, you can have your own color. I'll have a brown color for this. Same way, add DC VCC. This is also, okay, it is not a high power. Let me not give it as a high power. I will just give it a little power. And this one I will make it like a orange. Okay. Now, instead of this making it like I'll click on change net. I'll select DC ground. Okay, see wherever ground is connected, now it become a brown color. Same way I select second one, change net DC VCC. See, it has its own color wherever we use the VCC. Okay, so now we change something in the schematic, right? To forward the changes, you have to click on forward design changes. Click OK. So according to that, things are changed here. Okay. Yeah. Next thing is now I was informing you regarding the copper pour. So for copper pour, guys, you have to use one option called as, see, you can observe here there is an option called as the add area for copper pour. Add area for copper pour. So I'll give some space and I'll add it. Don't worry, you have a recorded video. You can practice it once the class is completed. Because these things has to be taught in one shot, in a one flow. That's the reason I am completing in a one class. Don't worry, this is not only the one circuit. We are going to do like this many circuits. I'm just showing you one flow completely. After that, like for every project, you have to do this. This PCB design is a common for all the projects that you are going to do. Okay, so everywhere copper pour is filled, but sir, still we didn't get any kind of copper area here because we didn't select it. You can observe here there's an option called as a add. Previously it was not enabled. Now since I added an area, right, that's the reason this is enabled. After this, we have to select which area we have to make it common area, common copper. Okay, if you click on this, now you can observe we got like a regular circuits, but still it is not updated here. Click on refresh. Zoom out. So see here, everywhere copper is there. Only that area it is isolation. If you want a more isolation gap, you can edit still. You can make it like a more isolation gap between the, see here it is telling the isolation gap and everything. See, that is. Okay. So this is the one thing. One more thing is whatever we did is everything is all about the back copper area editing. Okay. But PCB is not only about the back copper area, it also has a front area where you have to mention the information regarding your component name and everything. So for that, what you have to do, you have to first separate the areas. So click on interaction bar, go to layers. In the layers, guys, disable the bottom copper. Yes. If you disable the bottom copper, now you are getting only top seal screen. Now you adjust it according to the requirement. You can change the font size. So changing the font size we already know. So you have to go to settings, text styles, select the font. So Times New Roman you can select. You can increase and see. Right click, apply to column. Point 0.02. Apply. Yes. See now. LDR resistor. So if you want to display the value of resistor, double click on this, enable the value also. Just a minute. Double click on the component, double click on the text, only text, enable the value, apply. See now it is displaying given the value also, right? Same way, see anyhow we have a good space here. What we can do, we can move this component a little bit here, provided we should not get any error. Yeah, see we are getting the error. It means copper pour has to be before copper pour only we have to do that. Otherwise, after doing it, do the remain like one more time copper pour, you'll able to update. Double click on this, enable the value. Text you can change, but you should not change the component placement. This is the load, this is the power supply, rotate and power supply. And I want to give the title for this entire board. So I'll click on title saying that smart light. Okay, after that one smart light, you have to select a, see where I took this. Let me show you once again. Click add text, smart light, select top seal screen and place it here. So I'll add our company website www.indiantechkeys.com. Let me place it here. Let's do it. Clear? So if you want to increase the font size, double click, properties. You can increase the font size. Let me make it like a 35. It looks properly in the screen. Okay, now you see the 3D view. Refresh. Okay, it is not able to put beyond certain level. Okay, you can observe everywhere we are getting the information. See, smart street light, the component values, load, power supply. Clear, sir? But I want some information in the back end. So somewhere I want my company name to be displayed even in this text. In that case, so now let me consider I would like to display company name here, but in a very large font, ITK in a shortcut. Instead of top layer, instead of silk screen, you have to select a bottom copper. But it is throwing error because it is having the copper core, right? So what I will do now, I will just go for a copper core one more time. See, now separately it gave a isolation. Right. Now let me increase the font size and make it like a 65. Okay. So if I want to continue further, like it is showing the error because copper core has to be updated. Again, click on copper core, update. See now, like you should not move even the small 1 mm once copper core is updated. So after this, the final stage, that is exporting this one for the manufacturing. Okay, to export this one to the manufacturing, you have to go to tools. First you have to check DRC, design rule check. Click on check. You should get a no errors found. Okay, once again I'll show you. Tools, design rule check. Click on check. No errors found. Once that is done, go to output, manufacturing plots. Okay, AutoGen. We have a standard format for PCB files, that is a Gerber format. Okay, but for Gerber format you're supposed to have a separate software to view it. You can go with the PDF format as of now, which you can see in your systems. Okay, just click on OK, run. Yes. Okay, here you can see different layers. So this is the top documentation layer, top silk screen, bottom copper, solder mask, drilling holes, all these different layers. So now in this layer only we will come to know is there any still improvements required. So now I want this particular lines to be thicker, and the font also not enough for me. I want a font to be have a good view. So that's the reason I'll go here and I'll do some changes. So textiles, I'll keep it point 20. So when we kept it, we have to check where is there any kind of overlapping or something is happening. We have to cross check that. Nowhere overlap is happening. Next thing is I'd like to change the thickness of these boxes symbols. So that is the line styles. 0.6 I'll give. Yeah, now you can observe it is having the good thick. And now also we have to cross check is it overlapping anywhere with the information. For top silk screen, you don't need to go for a copper core because it is not having any dealing with the copper core. So once this is done, so you have to make sure that your old PDF file should be closed, otherwise you'll get an error. Output, manufacturing plots, AutoGen, Just a minute, I'll show you again. Output, manufacturing plots, AutoGen, PDF. Okay, run. Yes. Yeah, now you can check with the outputs here. Now we got a little bit big fonts and also the proper thing. And this is for manufacturing. Okay. This is the one type of view. One more view is, sir, I don't want a copper pour means without copper pour you'll get a one more view. So let me delete the copper pour. Only this much I'll take. I'll not have a copper pour. So again, output, manufacturing plots, AutoGen, PDF. Okay, run. Actually, whenever we are doing in an office for R&D purpose, we'll take this type of file, because copper pour needs a very high level of manufacturing industry. I mean, proper commercial manufacturing, whereas this one is not required. Clear? So like this track we are going to generally consider for our purpose. Yeah, I know it's a very lengthy one-shot training happened today, but the technology is like that. I had to take it in a single shot. That's the reason I took it. Any doubts, guys? I know you didn't practice. At least you understood the flow, right? Hello.
Yes, sir.
Yes, sir.
Yes. Okay. Okay, guys. So this is for the day. You be ready with you complete this entire design. I'll share the anyhow recorded session